So let's apply our geometric series test to this series. 3 over 2 to the n, where n starts at 1. So let's first write out some terms and see if we can figure out what this ratio is going to be. So if n equals 1, that's 3 over 2. Plus, if n equals 2, that's 3 over 2 squared, which is 4. Plus 3 over 2 cubed, which is 8. Plus 3 over 2 to the 4th, which is 16. So the question is, what is our common ratio, right? The numerator is not changing ever, and our denominator is changing. So what's our common ratio? So how we figure that out is you take any term, 3/4, and we divide it by the previous term, which was 3/2. Okay, and this works for any term in your sequence. You take one term and you divide it by your previous one. That should give you the ratio of your sequence. So what is 3/4 divided by 3/2? Well, we're going to multiply by its reciprocal. So the reciprocal of 3/2 is 2/3. And when we reduce 3/4 times 2/3, we get 1/2. So this is how we determine what the ratio is. So by our geometric series test, does this converge or diverge? It will converge. So let's see, this series converges because our ratio is less than 1 by the geometric series test. Wow, that's some sloppy handwriting right there. Okay, how about our second one? What is our ratio? If we have 3/2 to the n, 3/2 to the n, that means that's 3 to the 1 over 2 to the 1, and then 3 squared over 2 squared, and then 3 cubed over 2 cubed. Okay. So what is our ratio? That would be our second term, which is 9/4, divided by our first term, which is 3/2. Okay, so 9 over 4 times 2 over 3 reduces to 2 on the bottom. 3 over 2. Oh, look at that. So here's our form of our ratio. 3/2 is your ratio. So does our sequence converge or diverge? Diverges. Okay, by the geometric series test. Wow, so sloppy. Our function, do we have a function name? No, we don't have a function name. The function diverges because the ratio is greater than 1 or equal to 1, right? Because that's what our test said. If our ratio is greater than or equal to 1, it diverges. Here we have our ratio of 1.5. So that ratio is greater than 1, so our function diverges. Okay, what do we have next? We have geometric series, right? Some random, non-specific one. The first term is 108, and the third term is 12. So what's the value of your series? Well, we have to do all of our work and find that ratio, right? We have this formula up here that we're going to use to find that sum. But in order to use this formula, we need to know the first term and the ratio. So let's use our formula, which says a to the n equals a to the 1 times ratio to the n minus 1. Okay, you need to have this formula memorized in your brain so that we can apply it here to figure out what our ratio is. Okay, so what do we know? We know the first term is 108. What else do we know? We know the third term is 12. Okay, so that means we're going to put 12 here. This is our a sub n term, 12. Okay, we don't know the ratio. Oh, so then what is n? Right, that's the subscript of our term. So our n value is 3. Okay, so you put your nth term here, the actual term goes to here for a sub n, that's the term. Your first term goes there, and then n is the subscript of the term that we're given. So this subscript is 3. So 12 equals 108 times r to the 3 minus 1. Okay, let's solve this for r. Our first step is divide by 108. 12 divided by 108 reduces to 1 over 9, I believe. 9 times 12 is 108? Okay, 1/9 equals r to the second power. 3 minus 1 is 2. Okay, our last step is take the square root of both sides. What's the square root of 1 over 9? That would be 1 over 3, right? The square root of 1 is 1, and the square root of 9 is 3. So this has a ratio of 1/3. Okay, so we can find the sum by doing our formula, which says 108, that's the first term, over 1 minus the ratio, and we found out that ratio was 1/3. Oh, great, some more fractional math. So 108 over 1 minus 1/3 is 2/3. Rather than dividing by a fraction, we're going to multiply by the reciprocal. So it's 108 times 3 halves. Well, I know half of 108 is 54, right? 54 is half of 108. So 54 times 3 is 162. So all of the terms of this sequence, 108 r to the n minus 1, all of those terms would add up to 162. Okay, so this is a convergent sequence. Converges because the ratio is less than 1, and it converges to 162. Adding up all of these fractions, all these numbers, gets us to 162. Okay, our next test for convergence, actually, it looks like for divergence, is the nth term test. If the limit is not 0, then it diverges. Okay, so we're taking the limit of our function as n approaches infinity. Right, so if it is 0, that doesn't tell us anything. Okay. If it's 0, then that doesn't tell us anything. But if it's not 0, then it diverges. Okay? So looking at this one, we had one similar to this yesterday. Right? In order to decide whether this converges or diverges, we take the limit as n approaches infinity of our function. The limit as n approaches infinity. For infinitely large numbers, if we plug 2 times infinity over 3 times infinity, well, that's infinity over infinity. Okay, so we're allowed to invoke L'Hopital's rule. So we're going to take the derivative of the top and the bottom, which is just, what, 2 over 3? take the derivative of the numerator, which is 2, and the derivative of the denominator, which is 3. And the limit of a constant is that constant. Okay? So by the nth term test, the limit as n approaches infinity of our function is not 0. Therefore, the function, or in this case, a sub n, diverges. Okay, so that's the analysis piece. We perform the test, we look at what the test results are, and we do our analysis. These 3 dots right here, this is the internationally acceptable symbol for therefore. Okay, so here we have some other functions that we're going to use the nth term test on. So we're going to check out their limits and see if it's anything other than 0. Okay, so let's first of all write down some terms here, right? These are factorials, and factorials have a bunch of multipliers to them. So this is 1 factorial is 1 times 1 over 2 times 1. That's 2 factorial plus 1. This is 1 over 3. So that's our first term if we have n factorial over 2n factorial plus 1. Okay, so we're going to try and come up with some general things that we can actually take the function of, because factorials aren't good to do that for. So if n equals 2, that's 2 factorial over 2 times 2 factorial plus 1. Okay, 2 factorial is 2 times 1. 2 times 2 times 1 plus 1. Okay, remember, it's just the 2 that I am factorialing. And then I'm going to multiply that product by 2. Okay, so 2 times 1 is 2. This is over 5, so 2/5. It looks like I need some more space. So I'm going to come up here. We're going to do some more of these factorials. And we're going to see if we can find a function that will generate all of these terms. Okay, so here's a whole bunch of other ones. So let's write them down as a list here. So we have 1/3, and then 2/5, and then 6/13, and 24/49. Then we had 120 2/41. And then we had 720 14/41. And as we get bigger and bigger and bigger and bigger, we're noticing that the numerator and the denominator are basically, the denominator is double the numerator, right? This is basically n factorial over 2 times n factorial. And your n factorials basically divide each other out. So this will, the limit, let's write this correctly, the limit as n approaches infinity of n factorial over 2n factorial plus 1 is going to be 1/2. Okay, as we do more and more and more and more and look at these ratios, the numerator is 1 more than double the denominator. So we're getting closer and closer and closer to 1/2. So what does that mean for our sequence? That means that our sequence diverges because the limit does not equal 0. Okay, that's what it means. If our limit is anything other than 0, that function diverges. The series diverges. If we add up all these values, we add them all up, we're going to get not a single number. That's what that means. Okay, the nth series test, the nth term test allows us to do that. Okay, so we're going to do the same thing for this one, 3 to the n minus 2 over 3 to the n. Okay, if we're thinking about this one, the numerator is 2 less than the denominator. Okay, that would be like, these are just numbers, 998 over 1,000, right? That's not an actual thing because 3 to the n as an integer doesn't equal 1,000. But basically, if we took the limit of this for very large numbers, the limit would basically go to 1, right? The numerator is 2 units less than the denominator. So 98%, right? 0.98 over 100 is 0.98. That's getting closer and closer and closer to 1, which means that our function will diverge because this does not equal 0. So our function diverges by the nth term test. Okay, the nth term test says that if the limit is anything other than 1, then your function diverges. I meant 0. Anything but 0, then our function diverges. Okay, so here we have this telescoping series. Okay, notice what the telescoping series does. We can take this -1 and this +1/2. We can combine them. What's -1/2 plus 1/2? That's 0. -1/3 plus 1/3. That's 0. Okay, these telescoping sequences will always going to share some type of a value here. So let's see if this does it. If a series collapses to a finite sum, then it converges. So let's see what's going to happen here. Okay, if n equals 1, that's 1 over 2 plus 1, which is 3, minus 1 over 2 plus 3, which is 5, right? So that's the first one, 1/3 minus 1/5. Plus. So here are some other terms. So notice, right, if we keep going on and on and on, and we do because it goes to infinity, that this second term minus 1/5 and this third one positive 1/5, they give you 0. And then minus 1/7 and positive 1/7, that gives you 0. Minus 1/9 and a positive 1/9 will give you 0. And it goes on and on and on and on and on. So what is our first term here of our sequence? It is going to be 1/3. Okay, so if it collapses to a finite sum, then it converges by the telescoping series test. So this one will converge because the sum of our sequence or series of 1 over 2n plus 1 minus 1 over 2n plus 3 equals 1/3. Okay, so it converges because it collapses to just the value 1/3. Everything else will add or subtract out. Even if we go to an infinite amount, it's going to be so small, like 1 over 7 billion, which is basically 0, plus 1/3, which is going to be 1/3. Okay, telescoping series, they have terms that subtract each other as you get bigger and bigger and bigger values. Okay, just some things to be aware of and some tests that we can apply in order to see if these values converge or diverge.